2025 A-Level Combined Mathematics Paper 2 Part A, question number 2. This question in all papers usually has to do with projectile motion. This particular question says a particle is projected from a point O on horizontal ground with an initial speed u at an angle theta, which is some value in between 0 and pi by 2 radians with the horizontal. It then says that the particle moves under gravity. So if you consider the situation that we have here, we have some point O, which is some point on the ground like this. We project the particle upward like this at a speed u at an angle theta to the horizontal like this. Now if it's under gravity, there's going to be a constant downward acceleration, which I can mark with double arrows like this, g downward. Now if there is a downward acceleration like this, then as this particle is projected, it's initially going to be going up, but as it goes up, the downward acceleration is going to slow it down in the vertical direction, eventually leading it to it falling back down to the ground and hitting the ground somewhere over here. Now the question says, find the horizontal range of the projectile and show that if it is equal to square root of 3 u squared over 2g, then theta is either pi by 6 or pi by 3 radians. Now considering the horizontal range is referring to the horizontal distance travelled from the starting point to the ending point. So it's referring to this distance right here, which I'm going to label with capital R. So this is the horizontal range. What we need to do first is find the horizontal range, and then if it's equal to this, we need to show that theta could either be pi by 6 or pi by 3 radians. Now in pretty much all of these questions, in pretty much every single paper, every single year, all you really have to do here is to apply s equals ut plus half at squared in both the horizontal and vertical directions to obtain two equations, which you can then simplify based on the question in order to get your final answer. Now in this case, since they haven't given a time of travel, as in the time taken for the particle to go up and hit the ground again, we are going to have to define one. So what we're going to do first is to define that by saying let's say capital T be the flight time of the particle. So this means if we start a stopwatch at the point O and we stop it at the point when the particle again hits the ground, then the total time recorded by the stopwatch is going to be capital T. So now given this, as I said, what we're going to do next is to apply, we're going to apply s equals ut plus half at squared in both the horizontal and vertical direction. So I can represent that with horizontal arrow here and a vertical arrow here. Now considering the horizontal motion of this particle from the starting point until the ending point, it has moved horizontally in the rightward direction a distance of r. Therefore, if I consider displacement taking the right hand side as the positive direction, then the displacement is equal to r. Now r is going to be equal to ut plus half at squared, where this t here and this t here are going to be capital T. Now if we consider the acceleration a here in the horizontal direction, since we are assuming that there is zero air resistance, the horizontal acceleration is 0, and due to that, this entire half at squared term for the horizontal direction is going to be 0 directly. Now if we then consider this ut term in the horizontal direction, the initial velocity u is actually u cos theta, since the actual horizontal velocity is going to be u times the cosine of theta, since this velocity is the velocity in the direction which is an angle theta above the horizontal, but we want the velocity in the direction of the horizontal. So here, if we take this triangle and we consider the angles that we have, this side length here is going to be u cos theta, which means that the horizontal velocity of the particle is u cos theta, which needs to then be multiplied by the time, which is capital T. Now what we have here, r equals u cos theta times t, is going to be equation 1. If we now consider the vertical motion, in the vertical direction we can see from this point to this point, since the ground is horizontal, the vertical level of the starting point and ending point are the exact same. So if a particle travels from the horizontal, this point here, the starting point, to the ending point, it actually does not travel any displacement at all in the vertical direction. It goes up to this point by, let's say, height h, but then it also goes down by the same height h, meaning it actually travels 0 distance in the vertical direction. So therefore the displacement in the vertical direction s is going to be equal to 0. Now 0 is going to be equal to ut plus half at squared. If we consider the vertical upward direction to be positive and consider ut and half at squared, the u here is going to be the vertical component of our initial velocity, which is according to this triangle going to be equal to u sine theta. So therefore this value u here in this equation is going to be u sine theta, which will then be multiplied by capital T plus half at squared. But in this case, notice that the acceleration g is in the downward direction. Now if we took the upward direction as being positive, then the downward direction acceleration g is going to be negative. So what we actually have here is plus half negative g for the acceleration a times t squared, which is in this case capital T squared. So capital T squared. And this is going to be equation number 2. Now all we need to do is to use equation number 1 and equation number 2 in order to find the variable that we want, which in this case we are asked to find the horizontal range, so we need to find r. Now in order to find r here, we can see all we have to do is to substitute into this value t some expression from all of this stuff, which will then get us r in terms of only u and theta. So if we take a look here, we can see in this expression number 2, we can divide everything by a t, since here we have a value that has a t inside of it, and this thing has a value which has a t squared inside of it, which means it has a t inside of it. So if we take 2 and we divide out a t, minding of course that t is not equal to 0, we take 2, we can convert it into u sine theta plus negative. Actually we can do a little extra step here. Since we have all of this added together equals 0 and this is negative, we can take this negative component to the other side and write it as a positive component. So instead of plus half times negative g times t squared, we can have plus half times positive g times t squared on the other side. So we have equals plus half times g times t squared, but remember we are removing one of the t's, so therefore we have just t. Now again, we divided both sides here by t, so we need to mention that t is not equal to 0, and of course t is not equal to 0 since traveling from this point to this point is going to take some time. Now considering this thing, we can see that this rearranges to give that t is equal to 2u sine theta divided by g. Let's call this equation number 3. We can see now if we substitute directly equation number 3 into equation number 1, t is going to be completely eliminated and the expression for r is going to only be in terms of u, cos theta and sin theta and g. So if we do that, if we combine 1 and 3, we are going to get that r is equal to u cos theta times, and if we substitute into t this value, we get 2u sin theta divided by g. Now here we can simplify some things. We have r equals u times u, which is going to be u squared. Here we also have cos theta times sin theta times 2, and recall that 2 sin theta cos theta is equal to sin 2 theta, so we have sin 2 theta divided by g. So there we go, that is our expression for the value r, the range, or actually horizontal range. Now if we consider what we have next, it says that show that if the horizontal range is equal to square root of 3u squared over 2g, then theta is either pi by 6 or pi by 3. Now considering that if the range r is equal to square root of 3u squared over 2g, then we can see we have square root of 3u squared over 2g being equal to this value of r, which is going to be equal to u squared sin 2 theta over g. Now we can see if we divide both sides u squared and g, we're going to be left with sin 2 theta equals square root of 3 over 2. So we can see we're going to get sin 2 theta equals square root of 3 over 2, which is also equal to the sine of pi by 3. Now considering this, of course, there are an infinite number of solutions for sine 2 theta, since sine of theta or sine of any angle is going to be a periodic function. However, if you consider the range of theta that we're allowed, we're only allowed thetas between 0 and pi by 2. And due to this, there's only a limited set of values that 2 theta could be equal to. Now considering this, pi by 3 is one of the answers. We could either have 2 theta equals pi by 3. Additional to this, we can also have 2 theta equals pi minus pi by 3. And the reason we can have this is because if you have sine of A equals sine of B, the pattern is that A is equal to n pi plus negative 1 to the power of n times b. Now in this case, when n equals 0, we get the case that 2 theta is equal to pi by 3. But when n equals 1, we have n times pi, which is pi, 1 pi, which is pi here, times plus negative 1 to the power of 1, which is negative 1, times b, which in this case is pi by 3. So we get pi minus pi by 3. Now we cannot have any other values after this. We cannot, for example, have n equals 2 where we have 2 pi plus negative 1 to the power of 2 times pi by 3, because that would be equal to, if you simplify, it's going to be equal to 7 pi by 3, which is greater than 2 times pi by 2. 2 times pi by 2 is of course pi, which is the limit of our angle theta. Theta can only be in between 0 and pi by 2. So the value pi by 2 itself is going to be less than the value 7 pi by 3. So due to this, if you consider 7 pi by 3, 7 pi by 3 is greater than pi. So even the largest value of theta that we can allow is still too small. So due to this, any other solutions outside of this range are invalid. Due to that, the only two solutions we have is 2 theta equal to pi by 3 and 2 theta equal to pi minus pi by 3 or 2 pi by 3. Now as for the reason why these two are the only values, we can say in a bracket right here, theta is in between 0 and pi by 2, and since this is the first part, this logic right here is enough. Now if we simplify everything by dividing by 2, we can see that we get the two answers that we had in the question. Theta equals pi by 3 divided by 2 or pi by 6, and theta equals 2 pi by 3 divided by 2 or pi by 3, which are the two answers that we had in the question, pi by 6 and pi by 3. Now finally, if we consider the marks awarded for this question, drawing the diagram like this actually doesn't carry any marks. What does carry marks is applying s equals ut plus half at squared in the horizontal direction, which gets you a total of 5 marks, and the vertical direction, which also gets you a total of 5 marks. Now after this, when you use these two equations to simplify down and get r equals u squared times sine 2 theta divided by g, or you can also leave it at 2 sine theta cos theta, that's also allowed, times u squared divided by g, but I would prefer this thing, but you can also write this, it's also fine, you'll still get marks for that. You get another 5 marks for this. After that point, when you apply the condition that they have, where the range is equal to square root of 3u squared over 2g, and you simplify down to get sine 2 theta is equal to sine pi by 3, you get 5 marks. When you then say that there's an infinite number of solutions, but the only two valid solutions are 2 theta is equal to pi by 3 and 2 theta equals pi minus pi by 3 or 2 pi by 3, and you solve for the two values to get pi by 6 and pi by 3, you get another 5 marks. And that is going to be all for this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.